In today's digital age, data is the lifeblood of businesses and individuals alike. We generate an astounding amount of information every day, from financial transactions to social media interactions. This data is often stored in complex systems known as databases. But what happens when this valuable information falls into the wrong hands? This is where database forensics comes in. Imagine a team of digital detectives meticulously combing through the remnants of a cyber attack, piecing together fragments of information to uncover the truth. That's essentially what database forensics is all about, investigating databases and related systems to uncover evidence of security breaches, data theft, or other malicious activities. Database forensics is a critical aspect of cybersecurity, helping organizations protect their sensitive information and bring cybercriminals to justice. It's a fascinating field that combines technical expertise with investigative skills, requiring a keen eye for detail and a deep understanding of how databases work. In this essay, we'll delve into the world of database forensics, exploring its key concepts, techniques, and real-world applications. Get ready to uncover the hidden secrets lurking within our data. Why is database forensics so crucial in today's interconnected world? In an era where data is the new oil, safeguarding this valuable asset has become paramount. Simply put, data breaches are becoming increasingly common and sophisticated. Every day we hear about new incidents where sensitive information is compromised, causing significant financial and reputational damage to organizations. Cybercriminals are constantly finding new ways to exploit vulnerabilities and gain unauthorized access to sensitive information. They use advanced techniques and tools, making it challenging for traditional security measures to keep up. When a breach occurs, organizations need a way to determine the extent of the damage, identify the perpetrators, and prevent future attacks. This requires a meticulous and systematic approach to uncovering the truth behind the breach. This is where database forensics plays a vital role. It involves the application of investigative techniques to examine and analyze database systems, uncovering evidence of malicious activities. By analyzing database logs, transaction records, and other artifacts, investigators can piece together the events leading up to the breach, identify the data that was compromised, and gather evidence to support legal action. This process is akin to a digital autopsy, where every detail is scrutinized to understand the cause and impact of the breach. Think of it like a puzzle. Each piece of data recovered during a forensic investigation is like a puzzle piece. These pieces, when put together, reveal the complete picture of the breach. By carefully analyzing and assembling these pieces, investigators can create a clear picture of what happened, how it happened, and who was responsible. This comprehensive understanding is crucial for mitigating the damage and preventing future incidents. Database forensics is not just about reacting to security incidents, it's also about proactively strengthening an organization's security posture. By learning from past breaches, organizations can identify weaknesses in their defenses and take steps to fortify them. By understanding the techniques used by attackers, organizations can implement better security controls, educate their employees about data security best practices, and reduce the risk of future breaches. This proactive approach not only helps in safeguarding data, but also builds a culture of security awareness within the organization. Investing in database forensics capabilities is an investment in the organization's future. It ensures that when a breach occurs, the organization is prepared to respond swiftly and effectively, minimizing the impact and recovering quickly. In conclusion, database forensics is an essential component of modern cybersecurity strategy. It provides the tools and techniques needed to investigate breaches, understand the methods used by attackers, and strengthen defenses against future threats. As data continues to grow in importance, so too does the need for robust database forensics capabilities. Remember, in the digital age, staying vigilant and investing in strong security measures is the key to protecting your most valuable assets. Now that we understand the importance of database forensics, let's take a closer look at the key players in this investigative process. Database artifacts. These artifacts are the digital remnants that tell the story of what has transpired within a database. They are the silent witnesses to every action, every change, and every breach that occurs. These are essentially digital footprints left behind by users, applications, and the database system itself. Each interaction with the database leaves a trace, a piece of evidence that can be crucial in an investigation. Whether it's a user logging in, a query being executed, or data being modified, these actions are recorded and stored. They provide valuable clues that can help investigators reconstruct past events and uncover malicious activity. By piecing together these digital clues, forensic experts can build a timeline of events, identify the perpetrators, and understand the methods used in the attack. This process is akin to solving a complex puzzle, where each artifact is a piece that brings us closer to the full picture. Some common types of database artifacts include transaction logs. These logs record every action performed on a database, such as data insertions, updates, and deletions. They are like a diary of the database, documenting every significant event. By analyzing these logs, investigators can track user activity, identify suspicious transactions, and establish a timeline of events. This can be particularly useful in identifying unauthorized access or data manipulation. By analyzing these logs, investigators can track user activity, identify suspicious transactions, and establish a timeline of events. This can be particularly useful in identifying unauthorized access or data manipulation. For instance, if a large amount of data is suddenly deleted or modified, transaction logs can help pinpoint the exact time and user responsible for the action. Audit trails. Similar to transaction logs, audit trails provide a chronological record of database activity, but they typically focus on specific security-related events, such as changes to user permissions or access control lists. These logs are essential for maintaining the integrity and security of the database. They help ensure that only authorized users have access to sensitive information and that any changes to the database are properly documented. Database backups stop. Regular database backups are essential for disaster recovery, but they can also serve as valuable forensic artifacts. Backups capture the state of the database at a specific point in time, providing a snapshot that can be compared to the current state. This comparison can reveal unauthorized modifications, data theft, or other malicious activities. By comparing a backup taken before a suspected breach with the current state of the database, investigators can identify any unauthorized modifications or data theft. This process can be likened to comparing two photographs of the same scene taken at different times, allowing investigators to spot differences and anomalies that indicate tampering or intrusion. These artifacts are like digital breadcrumbs, leading investigators through the labyrinth of data and revealing the steps taken by attackers. Each artifact provides a clue, a piece of the puzzle that helps forensic experts understand the sequence of events and the methods used by the attackers. This trail of breadcrumbs can be followed to uncover the full extent of the breach and to identify the perpetrators. By understanding how to interpret these clues, forensic experts can piece together a comprehensive narrative of the attack. This narrative not only helps in identifying the attackers and their methods, but also in strengthening the security measures to prevent future breaches. The insights gained from analyzing database artifacts are invaluable in enhancing the overall security posture of an organization. While database artifacts provide a wealth of information, it's important to remember that the investigation doesn't stop there. In fact, focusing solely on database artifacts can sometimes lead to missing out on critical pieces of the puzzle. Valuable clues can also be found outside the database itself in what we call non-database artifacts. These artifacts might include logs, network data, and other digital breadcrumbs that can paint a fuller picture of the incident. Server logs. Web server logs, for example, can reveal IP addresses of visitors, pages accessed, and timestamps. These logs are like a digital footprint showing us who visited the site, what they did, and when they did it. This information can be crucial in identifying the source of an attack or tracking the attacker's movements. By analyzing these logs, we can often pinpoint the origin of the attack and follow the trail left by the attacker. Operating system logs. Operating systems maintain logs of system events, user logins, and application activity. These logs are like a diary of the system's activities, recording every significant event that occurs. These logs can provide valuable insights into the attacker's actions on the compromised system. By examining these logs, we can understand what the attacker did once they gained access, which applications they interacted with, and any changes they made to the system. Analyzing network traffic can reveal communication patterns, data transfers, and other suspicious activities. Network traffic analysis is like eavesdropping on the attacker's conversations, allowing us to see who they are communicating with and what data is being transferred. This is particularly useful in identifying command and control servers used by attackers to remotely control compromised systems. By identifying these servers, we can disrupt the attacker's ability to control the compromised systems and potentially trace the attack back to its source. Think of it like this. If the database is the crime scene, then these non-database artifacts are the security camera footage and eyewitness accounts that can corroborate the evidence found within the database itself. They provide context and additional details that can be crucial in understanding the full scope of the incident. By casting a wider net and examining these additional sources of information, investigators can gain a more comprehensive understanding of the attack and build a stronger case. This holistic approach ensures that no stone is left unturned and that all potential evidence is considered, ultimately leading to a more thorough and effective investigation.